Hi y'all, Miss Donaldson here, and today we're going to apply what we have learned so far about perfect squares, square roots, perfect cubes, and also cube roots. If you guys recall, we began by discussing what a square was. And again, remember Miss Donaldson cannot draw, so here's a square. We first talked about the characteristics of a square, how a square has four equal sides, and that was important. Because it wasn't four equal sides, we knew that all the sides had to be the same exact measurements. Then we went and discussed the area or the inside of a square. Remember, the perimeter is outside, area is the inside. So, for example, let's say that I have a square and its measurement is 5 inches. So if I'm given that one dimension is 5 inches, I know that all the sides of my square, because they're four equal sides, have to also be 5 inches. Now, in order to find the area, you guys know the formula as area equals length times width. Please do not get that confused with perimeter. Perimeter is where you add all the sides on the outside, which would make it 20. But for area, I'm only going to take two side lengths and I'm going to multiply them by themselves. So my length will be 5 and my width is also 5. So when I go through and multiply the 5 times 5, that gives me 25. So the area of this particular square is 25 inches squared. If you recall, we also discussed about, besides saying 5 times 5, we could also write that using an exponent. The exponent that we're going to use is the exponent 2. This exponent is also called squared. Reason being is when you take a number and you multiply it by itself, you're really, again, representing a square because the side lengths are the same. So 5 times 5, or 5 squared, equals the same thing as 25. Then from there, we went along and then we found the first 25 perfect squares. Let's review a couple. So we learned that 1 squared equals 1, 2 squared equals 4, 3 squared, or 3 times 3 is 9, 4 squared is 16, and then 5 squared, again, is 25. Then from there, we discussed the inverse of squaring a number as being the square root. So for instance, again, let's go back to our square, and again, Miss Donaldson cannot draw. Let's say that I gave you the area. I told you that this square had an area of 36 inches. So we had to figure out what was the side length that I began with, or that I used to find the area. We discussed this as area as being the perfect square and the side length as being the square root. When I say square root, is we're not dividing by 2. We're trying to figure out what number times itself will give me 36. So basically, the square root of 36 equals, in this case, will give me 6. Because I know that 6 times 6 equals 36. But if you guys remember on Friday, when we added our vocabulary cards and our flashcards, we talked about how square roots, in general, is positive or it can be negative. Because remember, 2 positives also give me a positive. But on the other hand, if I take 2 negatives, thinking of my integer rules, that they will also give me a positive. That is why, by taking the square root of a number, you will have a positive or a positive or a negative number. Now, let's apply what we've learned so far about squares and square roots to a real life application problem. So, as you can tell, in this problem, we're talking about a person named James. It says James wants to buy a new rug for his room. In a store, he finds a rug that is 9 meters squared. What is the side length of the rug? Now, Let's draw out a picture to represent what we know about the rug. So we know that the rug is, first of all, it's a square. And again, I know mine looks like a rectangle. Remember, Dawson can't draw. We know that on a square, all the sides are equal. We know that the area equals 9 meters squared. And again, we know that area is the inside of the rug. So I'm going to, inside my square, I'm going to write 9 meters squared. So basically, I'm working backwards. I'm given the area. And we know that area represents the same thing as the perfect square. So since I have the perfect square, I know that I'm looking for the opposite or the inverse or the square root. So the square root of 9. Now, I need to realize or try to figure out what number times itself equals 9. I am not dividing by 4. I am not dividing by 2. Remember, when you find the area, you multiply the same number by itself twice. That is not the same thing as saying you're multiplying by 2. So, when I think back to my perfect squares, I know that the square root of 9 is positive or negative 3. But in this case, since we're applying it to a rug, I know that my side length cannot be negative. So I'm going to use the principal square root or the positive square root, which is 3 meters. So that means that the side length of the rug that James is looking at is 3 meters long. Let's look at another example that involves the application of perfect squares and square root. Example number 2. Jessica has a square picture with an area of 900 square inches. Dan has one that is 625 square inches. What is the difference between the size of the pictures? Now, again, I'm going to start by drawing out my 2 pictures. So I know that the first picture has an area of 900 inches squared. And then my second picture has an area of 625 inches squared. So same thing as before. They're giving us the area. And again, I know that the area is the perfect square. So I'm having to work backwards. So I need to figure out what is the square root of my areas of my pictures. So the first step I need to do is figure out what are those perfect squares and what are their square root. So inside my problem, I put the square root of 900. Since 900, again, is the area, that's my perfect square. So again, I'm not dividing by 4. I am not dividing by 2. I have to figure out what number times itself will give me 900. When I think of that, I know that it is 30. Now I'm going to go to my next one. 625 is the area. Again, that's the area. That is the perfect square. So I need to work backwards or find the inverse, which is to find the square root. So the square root of 625, which I know is 25. Again, we learned that square root can be positive or negative. But since I'm working with an application and I'm talking about distance of a particular object, I know that its length cannot be negative. So I know it has to be the positive, again, or the principal square root of that particular number. Now, I know that the first side length of the first picture is 30. And then the second side length of the second picture is 25. Now, the second part of the question asks me to find the difference. And you guys all know that when I say difference, I'm referring to the operation of. Now, let's look at an example where we have to look at or use cubes. It says the volume of a cube is 64 centimeters cubed. What is the side length of the cube? Again, I'm talking about cubed, which has 3 dimensions. So it has a length, a width, and a height. So to find the volume of a cube, I take that length, I take that width, and I take the height, and I multiply it by each other. And again, since it is a cube, and again, Miss Donaldson cannot draw, so maybe you guys can kind of see what I'm trying to do here. If I take that cube, I know that all my sides are equal. So basically, I'm taking the number and I'm multiplying it by itself, not 2 times, but 3 times. That's why we say cubed when we have the exponent of 3. So if I know that the volume is 64, I'm not going to take the square root of that, but instead I'm going to take the cube root. Again, because I took 3 of the same numbers and I multiplied it by itself. Now, again, I am not going to divide by 4. I'm not going to divide by 3. Remember, cubed is an exponent. So it means that I'm multiplying a number by itself 3 times. So I got to figure out what number times itself 3 times will give me 64. When I think of that, I know that 4 times 4 times 4, again, that is not 12. I'm not adding. I'm going through and I'm multiplying 4 times 4, which is 16. Then I'm taking that and multiplying it by 4. And that gives me 64. So that lets me know that the cube root of 64 is 4. So that means that the side length or the edge of that particular cube is 4. Now, unlike the perfect square, cube roots will always be positive. Now, let's think of a reason why that is. Remember our discussion on Friday. When you look at cubes, you're taking a number and you're multiplying it by itself 3 times. If you take 3 positives, okay, it's going to be a positive. But remember your integer rules for multiplication. 2 positives will give you a positive. But if I take an odd number of negatives, like 1 negative, 3 negatives, 5 negatives, I'm going to have an odd number. So that's going to make my answer end up being negative. That is why when you're talking about the cube root of number, they will always be positive. Now for our last example. I have 2 cubes here. The first cube, its volume is 1,000 inches cubed. The second cube, its volume is 125 inches cubed. I want us to figure out, to look and to decipher the difference between, again, the side lengths of both cubes. So again, I'm looking at the cubes. I know it's the volume, which is the area on the inside. So I'm going to shade this in. So again, you guys know to find the volume of either cube is length times width times height, which lets me know I'm taking the same number and I'm multiplying it by itself 3 times. So to the inverse of a cube is to find the cube root. So I need to figure out what is the cube root. And notice, guys, I added that 3 in my radical. Just a radical with no number on the inside means square root. So that's why you must add that 3 inside your radical. Again, the cube root of 1,000, we guys know is 10 because we worked on the flashcards last week. Now, again, take the cube root of 125. Again, that's one of those we already know from the flashcards. That gives me 5. So that lets me know that the side length of the first one is 10 inches and the side length of the second one is 5 inches. Now, to find that difference, again, difference means to subtract. So 10 minus 5 gives me 5. So again, my answer for the distance between the side lengths or edges of both cubes is 5 inches. Alright guys, that concludes our video lesson for today. I hope you enjoy. Remember, this will remain on our Google Classroom page. So if you have any questions or you guys would like to go back and look at it again, please feel free to do so. I will catch you guys later.